Okay, so good afternoon to everyone. One.
Good
So
afternoon, sir.
at first I will show the syllabus of your lab, then I will explain one by one. Okay. So this is the our list of experiments which are will be shown in this lab classes. Now you see in the list of experiment first there is a using of stack of characters convert from infix string to postfix string. You have already studied that during the uh, data structure classes, that how to convert infix string to postfix string, and that is shown in this class. It will be shown the programming of these things. Next, there is the experiment of implementation of insert and deletion of searching of a binary search tree, means binary search tree and linear search programs, then implement of a heap sort using maximum heap, then implement of DFS, BFS for a connected graph. And after that, some of the shortest path algorithm. Some of the shortest path algorithm, that distress algorithm, Huffman coding algorithm, this will be explained. And after that, some sorting techniques, quick sort, merge sort. These programs will be shown in the lab classes. And after that, matrix change multiplication, knapsack problem, and then dynamic programming approach and n-queens problem. And at last, there is a backtracking using game tree. So all of these are present on your syllabus. And today I will start first program, that is using a stack of characters and convert using a infix string to postfix string. I will start that. So before starting the program, I will explain how it works. First, I will explain that how it this works. I will explain it. Now, you already know that how to convert the infix string to postfix string. In data structure, I think you have already known and familiar with this. Is it familiar with this? Are you familiar with this? Infix, postfix, prefix. These are the techniques. So now, first, how to convert a string, that is in the infix string and the postfix string. So first, infix string means that the string or the operand, the operator will be present inside the operand, means it will be between the operand. The operator will be between the operand. And in the case of postfix expression, the operand will be first, and then after completion of the operand, the operator will be placed. But in case of infix string, the operator will be present between the string. So first, we will take an example, and that will clear your views, that here, this is x plus y. You can see this is a x is an operand, y is also an operand. And between them, an operator is present. So that's why it is called infix string. That's why called it is infix string. So how we can convert an infix string to postfix string? First, we have to create three part. That one part is character, one part is stack, and another part is postfix. So first, the character will be consumed. And one thing you should remember, that operator can be loaded in the stack, but operand are directly goes to the postfix expression. So first, we are consuming x. X is an operand. So it will not go to the stack. It will directly goes to the postfix expression. So that's why the stack is empty. And the operand will directly goes to the postfix expression. Next, there will be plus. Plus is an operator. Plus is an operator. That's why it goes to the stack. And then the postfix expression, in case of postfix, the value will be as same x. And after, then y will come. Then if y will come, y is an operand. It directly goes to the postfix expression. So now, after completion of it, the item or the operator present in the stack will be unstacked. Then xy plus. That's how we had convert an infix string to postfix string. Clear? This example is clear?
Yes, sir.
Okay. So it is a simple example to convert an infix to postfix string. In next example, we will see if there is a open parenthesis and closing parenthesis present, then how can we convert this infix string to postfix string? In that case, you see, first the character is consumed. Whenever there is an operand, it directly goes to the postfix expression. So x directly goes to the postfix expression and stack is empty. Stack is empty. Then here plus operator is taken. So whenever the plus operator is consumed, it will goes, it is an operator, so it will goes to the stack and nothing will go to the postfix expression. So as it is the previous, it will be x. Then the parenthesis, our open parenthesis comes. Now, one thing you should remember that if there is an open parenthesis, then directly push into the stack. One thing you should remember that if there is open parenthesis, then we didn't think anything. We directly push it into the stack. And no need to consider how many operators are present in the stack during operation. We have to not need to consider that how many operators are present, already present in the stack. We directly push the open parenthesis into the stack. Here you can see that open parenthesis is directly pushed into the stack. So no values will go to the postfix expression. So the postfix expression will be as same. That it will already, that x is previously it is x and now it is also x. After that open parenthesis, our next character comes y. Our next character comes y. So y is a operand, and that's why it will be directly goes to the postfix expression. It will not go to the stack. It will directly go to the postfix expression. Okay. Next, our after y character there is a into operator. So into operator will goes to the stack because we know that operator will go to the stack. So that's why into operator is goes to the stack. And in our postfix expression, it will be as previous xy. After that, the next character that comes is z. Z is an operand, so it directly goes to the postfix expression. So now our postfix expression became xyz, and in our stack, the three operators are present, that is plus, open parenthesis, and into. Now, after z, the closing parenthesis comes. Now, one thing I should say that if in the top of the stack, open parenthesis present, then there is no need to check the priority of the operator present in the stack. So if open parenthesis present in a stack, then there is no need to check the priority of the operator present in the stack. Otherwise, when we push a new operator in a stack, when we push a new operator in the stack, we have to check the priority with the existing operator. That means whenever we will push some operator, if there is existing some operator, then we will compare them between them with priority. Now you can say, what is the priority? You know that Bodmer's rule is applicable. Bodmer's rule means bracket, division, multiplication, addition, subtraction. This wise priority is considered. That's why that with this priority is considered. So if there is no parenthesis, then we have to, if we push a new operator in the stack, we have to check the priority with the existing operator in the stack. But here we have the open parenthesis. So there is no need to check the priority of the operator, which will push into the stack. Now, after consuming Z, there will be closing parenthesis comes. Now, whenever the closing parenthesis comes, then it is mentioned that if closing parenthesis goes to the stack, then we have to unstack all the operators present in the stack. So that's why whenever the closing parenthesis comes, we unstack all the operators. And so in our top of the stack, there is star, or we can say it is a into multiplication. So multiplication will be unstacked first, then the plus operator will be unstacked. But one thing you should remember, that during the postfix expression, we didn't use open parenthesis or closing parenthesis. So whenever we write the postfix expression, there is no need to mention open parenthesis and closing parenthesis. So if any infix expression, parenthesis will become, parenthesis is there, during the postfix expression, there is no need for parenthesis. For writing parenthesis, there is no need for writing parenthesis. Clear? If there is parenthesis in our example, then how it should work?
Yes, sir.
Anyone has any question till now? Anyone has any question?
No, sir.
Okay. If anyone has any question, then he or she may ask. So this is the second type in our example. And at last, we will see another type, that is third type. In this third type, I will show if there is no parenthesis. If there is no parenthesis, then how it should work. And there is more than one operator present in the infix expression. Then how it should work. You can see in this infix expression, there is x into y plus z, means more than two operators are present in this infix expression. So first, same as that previous, we have to divide it into the three parts: first character, then stack, then postfix. We can make a table with three parts. Now, first the character will be consumed. So first character is x. However, in our example, the first character is x. So this x will directly goes to the postfix expression, and the stack becomes empty, because we know that operand will directly go to the postfix expression. So it directly goes to the postfix expression. Then after that, there is the operator multiplication. So this operator will directly goes to the stack, and postfix expression will be as previous. That is, previously it is consumed x, and now it is also there, x is present. After that, our value will be, character will be y. So y is consumed, and y will directly goes to the postfix expression. So x and y. And after that, the another operator, plus operator comes. Now in this, whenever the plus operator will be came, whenever the another operator will came, we have to check the priority. Now, in this example, there is no open parenthesis and close parenthesis. So I have mentioned that I have, if there is no closing or open or closing parenthesis, then we have to check the priority with the help of, with the top of the stack. If the operator which we are going to, if the operator which we want to push has the highest priority, then the top of the stack, we can push the operator onto the stack. But in this example, star operator, which is the highest priority, we have to push the stack. We have to push the operator. If it has the highest priority, then we can push it into the top of the stack. If the operator which we are pushing is not has the highest priority, then we will not able to do it. Like in this example, plus operator. In this example, you can see there is, we have to push plus operator. Now, plus operator has the low priority than multiplication. How? Using Bodmer's rule. Using Bodmer's rule, you can see first multiplication, then addition. So addition has the lowest priority, then multiplication. But any item you have to push and it will be in the top of the stack. So how we can use that? So for pushing the plus operator, so for pushing the plus operator into the stack, we have to unstack multiplication operator, because multiplication has the highest precedence, or we can say highest priority. So how can we push plus operator into the top of the stack? It is not possible. If one way we can do this is to unstack the highest priority operator, then we can able to push the lowest priority operator to the top of the stack. In this case, multiplication is the highest priority. Multiplication has highest priority and plus has the lowest priority than multiplication. So we have to unstack our multiplication. Then we can able to push the plus operator into the top of the stack. So that's why you can see we unstack the operator. The multiplication which is present into the stack is unstacked from the stack and goes to the postfix expression. That's why here x, y star. And after that, we can able to push the plus operator into the stack. So that's why after doing this operation, the plus operator is pushed into the stack and the postfix expression will be as previous, which is xy multiplication. Then after that, z operand will came, and if this is operand, so it directly goes to the postfix expression. And after completion of this, the value which is present into the stack will be unstacked. So plus is present into the stack and this plus is unstacked after that. So these three examples I have mentioned because this is a three types. If there is a simple only one operator present, then it is very much simple. And if, but you have to remind one thing during the open, if the infix expression has the open parenthesis and closing parenthesis present, then you have to remember that in that case, priority is not the main thing. We have to push from the stack without the priority checking. But in case of this, the priority will be checked because there is no open parenthesis and closing parenthesis present. So this is the three type of example for infix to postfix expression. Clear? समझ में आया सबको?
Yes, sir.
ओके और बाकी लोग का?
Yes, sir.
ठीक. So this is all about infix to postfix expression. Now we will see how we can do the coding of infix to postfix expression. Now you can see this, how we can do this infix to postfix expression coding. Now first we have mentioned, and one thing you should know, that the program which will be done in this lab classes, I will do it in the C environment, C++ environment, not we are using the C language. And this we are do this program using C language, and we will use the compiler dev C++. That the all the programs here are present, we can do in simple C language. You all know the C languages. I think in the second semester you have all done the C programming, so it will be easy for you also. And that's why we will do all the programming that are present in the lab design of analysis of algorithm. It will be done in the using C programming, and we will do it in the C compiler dev C++. In the dev C++, we will do this programming. Okay, so first let's start the program of infix to postfix operation. Now you can see that I have the thing that is mentioned, it is called the comment. It is called the comment. For a good program, you can write the comment. Through comment, the main thing is that it clear to the other person. In case of other person, if you can write the comment, it will be clear to for other person. That's why it is not necessary that you should write the comment, but I have written for you that this comment is written for you. I have written it, but there is not necessary that you have to write also this comment. It is not necessary. So let's start. Now this program converts the infix to postfix expression, and this program assumes that there are 5 operators. In this program, I have mentioned this program will work on the 5 operators. That what are the 5 operators? Multiplication, addition, then division, then subtraction, and another one is power. So this we all know that in Bodmer's rule also, these are the 5 operators we present here. And in this infix expression, the operands can be of a single digit only. So for infix expression, the operand should be single digit, means x, y. It is not possible that it is xx, or we can say the triple x or double triple y. This is not possible. You have to only a single digit. For this, you have to be only a single digit should be present. And this program will not work for the fractional number. In case of fractional number, this program will not work. And this further, this program doesn't check whether the infix expression is valid or not in terms of number of operators and operand. Means this program will not check the infix expression valid or not based on the number of operators and operand. Means based on number of operators and operands, it will not check that. Okay, so first let's start the program. Now here I have mentioned hash include stdio.h. I think you already know that what are this of header files means. You all know that. Then I will not explain that. You know that, I think.
Yes, sir.
Okay. So you already know that hash include stdio.h, what is for, it is for it. Then another header file that is mentioned, hash include stdlib.h, and this header file we have their exit function are mentioned, so we will use it, and that's why stdlib.h we use the header file. And then a header file is mentioned, hash include ctype.h. This is a C standard library, declares functions that are useful for testing and mapping characters. Now, that's why I have written this comment, that it will be easy to understand you that this ctype.h header file is basically a C standard library which declares several functions that are useful for testing and mapping characters. Okay, so these are the useful for it. Then hash includes string.h. I have mentioned string.h because we are using a infix string and postfix string. So we are converting the infix string to postfix string. So the string is used, and then for using the string, we have to use the string header file. So that's why I have mentioned hash include hash include string.h. Then hash defines size 100 means the size I have mentioned, this 100 is mentioned for that the stack size. Mainly the for stack size, I have directly mentioned that the stack size should be 100. That's why you can see here the size in the characters cat stack. In the cat stack, the size is mentioned. The size is of 100 means the stack size. Here I have used to a stack used to be used, and we are globally declared that. Here we are declaring globally, and so that it is used more than one function. That's why we are defining it into globally. So the stack size, our stack size will be 100. Okay, we have mentioned that. And in top equal to -1, you know this statement condition. If top equal to -1 means our top is empty. Our top is empty. That's why if for mentioning it is empty, we use -1. You already know that data structure, you have seen this. So now for this program, we have to use 5 functions, 5 user defined functions we have to mention here. Now, what are the 5 functions? Push, first push operation, then next pop operation, push pop, and after that is operator, and then precedence, and at last a function which converts infix to postfix. Now, if we try to execute it, then first we have to start it from the main method. So our program will start its execution from main method. So here I have mentioned, you can see that main, I have mentioned the main return type. That means it will return some value. That's why I have used int main. And then inside it, the 2 variables are mentioned. 2 strings are mentioned, char infix size and postfix size, because these are the string, or we can say the character array, mainly the character array. This is the character array of infix string, and this is the character array for the postfix string. This is the array because infix 100, postfix 100. I have already hash define, using hash define, I have already mentioned it, that the size should be 100. So these are the character array. Infix size, this is a character array. Postfix size, this is also a character array. Because we have to convert infix string to postfix string. So that's why we have to use this too. That's why we have mentioned, declared, or here infix size and postfix size of character type. Okay. So now after that, we have to using the print statement. The print statement, I have mentioned that the infix string contains single letter variables, the and single digit constant only. It is dependent upon you that what you should write in the infix string. And now the infix string we are using getS method. Now what is the getS method? GetS method, you can know that for string we use getS method. It is like the scanf method. GetS is like the scanf method. So using scanf method, we can the input which is given by the user, we get it through the scanf method. Now, in the string, we use getS method. In case of string, we use getS method. So as a user, we will enter the infix string. So the infix string will be used as a getS, means we will take the infix string. The system will take the infix string. So as that's why it is used getS. Next, there is a method mentioned, a method or a function. Mainly a function is mentioned infix to postfix, and there as a parameter we are passing infix and postfix. Now this is here, it is a function definition. It is called, this is called a function calling. Now this is a function calling. This is in the main method, we are calling this function. But if we have to call this function, this function definition should be written another place. So here in this main method, we are using the function calling. So infix to postfix, this function having two parameters, infix to postfix. So we are only using function calling here. Function calling should be a one statement. A function calling should be of a one statement. And then after this, here the infix string will be converted to the postfix string, and we will print it through putS. PutS is used as a for printing. In string, we use putS method for printing the value. For printing the value, we use putS method. But this is all about the thing which will be do. Now we have to mention, we have already mentioned the function calling here, but this function should be declared in somewhere. This function should be declared in somewhere, and in this program this function is only not needed. The function which I have shown are all needed to convert for an infix string to postfix string. So now we will say one by one the function definition. So I have mentioned that I have to use a function called push, because the string, infix string, you can see that in infix string the stack is used. In infix, to converting an infix string to postfix string, a stack is used. So for stack, push and pop operation should be mentioned. In case of stack, the push and pop operation should be mentioned. So that's why first we have to use the push operation. Push, you know this function, push, and its return type is used as void. And in push operation, we push the item. We push an item. If our top greater than equal to size minus 1, means our top is the size, the mentioned size, and our top is greater than that, then that means our stack
The
is
stack is empty.
overflow. Overflow. Stack means the stack is completed. If the top greater than the size minus 1, if stack will be empty if top equal to minus 1,
Minus
or
one, yes.
or top less than equal to 0, then the stack is empty. Okay, so here we have to mention if else condition. In if else condition, first if there is mentioned if top greater than equal to size minus 1, that means our stack is overflow, means we cannot put operators in the whatever for infix to post conversion of infix to postfix string. What the things we store in the stack, the operators, we store the operators into the stack, means it is already overloaded, so we cannot able to do it if top greater than equal to size minus 1. And in else condition, if top equal to top plus 1, if there is empty, the space is empty, then we will increase the top value, and in this top value we will put the item. This is the stack push condition. Clear? It is clear?
Yes, sir. Yes, sir.
Yes, sir.
Till now the program is clear, that how the program should go, as that's how the program should go like. Okay, then pop operation should also be mentioned, because when the case is unstacking the, in the case of unstacking the operator, in the case of unstacking the operator, that is basically of, that is basically pop operation. That is basically pop operation. So we should have pop operation also. In this pop operation, if top less than 0, then stack is underflow and invalid infix expression. We can say invalid expression. And the get char is used. Get char is used for taking the character one by one. This method, get char method, will be used. It will be take character one by one. And if top less than 0, then the stack is underflow, and means there is nothing in the stack, there is nothing. So it will be an invalid expression and it will be exit from there. Otherwise, if means we didn't have something to pop from the stack, that's why it is empty. We didn't have anything to pop from the stack. That's why if top less than 0, that it will be an invalid infix